Calculus part 11. We continue. We will look at few more questions from the examination question papers. Determine f dash x from first principles. If f of x equal to minus 5x square plus 3x. Already we know the method. We have to write all the steps until we get the derivative. F of x equal to minus 5x square plus 3x, then f of x plus h. Replace x with x plus h and expand very carefully, then simplify. Okay, so we get minus 5x square minus 10xh minus 5h square plus 3x plus 3h. Then we subtract fx from f of x plus h. Okay, so we can check whether we simplify some, cancel some terms. Yes, minus 5x square and plus 5x square will be cancelled. Plus 3x and minus 3x will be cancelled. We are left with the minus 10xh minus 5h square plus 3h dividing by h. That is our third step. We divide, take h as a common factor and then cancel. We get minus 10x minus 5h plus 3. We introduce the definition of the derivative. F dash x equal to limit h tends to 0. F of x plus h minus fx over h. Then we substitute 0 for h. And finally we get the answer minus 10x plus 3. Calculate g dash 4. If gx equal to 1 over 2 root x. It's not g dash x. We have to go further and calculate g dash 4. Okay, let us start using the rules. Gx equal to 1 over 2 root x. Modifying the equation, half x to the power minus half. We must get the exponential form. Do it very carefully. Therefore, g dash x equal to half times derivative of x to the power minus half. That is half times minus half x to the power minus 3 over 2. That is your 1 mark. Now, simplifying, we get minus 1 over 4. X to the power minus 3 over 2. G dash of 4 now. In the place of x, we have to substitute 4 and use the calculator. At this stage, we get minus 1 over 32 as the answer. Determine dx of, another notation for the derivative. Dx of 2x minus 3 whole cube. Again, we come to whole cube here. We have seen the derivatives before, but I'm just explaining it once more how to get the cube. If you don't remember the shortcut expansion method, we do it very carefully. 2x minus 3 times 2x minus 3 whole square. Expand the square carefully, remove the bracket, simplify as much as possible. We get 8x cubed minus 36x square plus 54x minus 27. That is the extra job. So derivative of the equation now is derivative of 8x cubed. 8 times 3x square, that is 24x square. 36x square, that is 72x. And derivative of 54x is 54. Derivative of minus 27 becomes 0. So we get the final answer. Okay, again we come back to a question from cubic graph. The equation is available, but there are some unknowns, C and D. There is one point D. Okay, the turning points are there. The x coordinates are given. What is our question? Show that C equal to minus 18 and D equal to 32. So here two unknowns, C and D. What we do first? We have the turning point and the X coordinate is available there. Okay. So turning point. What is the connection between turning point and calculus? The derivative. Okay. H dash x must be equal to 0, the derivative equal to 0 there at the turning point. Now h dash of minus 2 or 3 we can use. We substitute 3 here, we write 3 times 3 square minus 3 times 3 plus c. So the unknown is c, we solve for c there. We get c equal to minus 18. Now the next unknown is d. Okay, we use any available point on the graph. What is the point available? 4, 0 is available. So we substitute x 4. X is 4. We substitute and solve for d. Use the calculator. And d is equal to 32. So we got the two unknowns. Question B. Calculate the coordinates of A. Now we have the equation. We calculated C and D. We have the full equation now. And the x coordinate is available. X coordinate of A is minus 2. So we substitute and get the y coordinate. What is the y coordinate? When you use 2 in the place of x, use the calculator very carefully. You get 54. So the coordinates of A is minus 254. Okay. Question continues. Determine the x value of the point of inflection. Only 2 marks. X coordinate, only the x coordinate. We must know that the x coordinate of the point of inflection will lie at the middle point of the x coordinate of the turning points. What are the x coordinates of the turning points? Minus 2 and 3. Find the middle point. Then we get the x coordinate of the point of inflection. So minus 2 plus 3 divided by 2, which is half. Look at the x coordinate of the point of inflection. That is the point of inflection. We have one more method. We know it. Find the second derivative of the function. So we have hx already available. H dash x, that is the first derivative. Then we find the second derivative. We get 6x minus 3. And we must know that at the point of inflection, the second derivative is equal to 0. Okay. Therefore, 6x minus 3 equal to 0 and x equal to half. That is another method. You can do any method. It's only 2 marks. Write down the interval for which h, the graph is concave up, 1 mark. So it depends on the point of inflection. I'm marking the point of inflection, and we know the x value at half. X is half. We have calculated that. From half onwards to the right, the graph is concave up. So that is our answer. X value of the point of inflection is half. The graph will be concave up from x equal to half. What is the answer? X is greater than half. Okay, that is our answer. If gx equal to h of minus x, what is the meaning? We give another name for the function. H of minus x is called gx, that is all. Write down the coordinates of the turning point. Okay, that is the image of A. H of minus x, you can see that it's a reflection along the y-axis. Okay, x becomes negative x. So what will be the image of A? the x coordinate will become opposite or negative. So minus 2 will become positive 2. That is the only difference. The image of A, that is the question. Image of A is A dash. So it is going to be 254. Just showing you the image there. Okay, look at that. So that is the answer. Determine the values of k for which hx is equal to k. Has two unequal negative real roots and one positive real root. Only 2 marks, good people. These are very clever questions. Hx equal to k, meaning another line k, y equal to k, like that. So we need 2 negative real roots and 1 positive real root. Okay, what is the method? I'm going to give you the method. Just draw a line y equal to k, or use your ruler. Move the ruler or this line. Think that we are moving the line. Okay, look at the line from the bottom. Now how many roots? How many roots are there? The point of intersections. Okay, that is, we have 2 roots. Look at the x values. Okay, you can see one value is 3, the other value we don't know, but there are 2 roots. Our question is not that. Moving the line again upwards, look at the answer. 1 negative root only on the left side of the y-axis. So we have 1 negative root and 2 positive roots. We can see that the roots are on the x-axis. Look at the arrows. Now again we continue. Look at this. If you go up, again we have only 2 roots, the points of intersection and the x values on the x-axis. You can see that in blue line. I'm just explaining it. Although it is 2 marks, we must be able to answer it in 2 minutes or 1 minute. Now, where is our answer? Look at this line now. Okay, if the line is there, we have 2 negative roots to the left of y-axis and 1 positive root in the right side. So that is our position of the line. So what are the values of y equal to k? See, at that point it is 32. Between 32 and 54, y coordinate 32 and y coordinate 54, or y values 32 and 54. Between 32 and 54, you can have 2 negative roots and 1 positive root. So the value of k, y equal to k, between k is, that is our question. Write down the values of k. So the values of k is between 32 and 54. You can even write in English or you write in notations. 32 less than k less than 54. That is our answer. Now at last we come to the application question. Application of calculus. The diagram is very clearly shown. The explanation is there. Calculate the smallest possible area. Smallest, that represents minimum. Okay, highest, maximum. Here it is the minimum possible area. So we apply calculus. Calculate the smallest possible area of triangle ABC. What is our idea? We have a rectangle. Inside the rectangle we have a triangle. So the basic idea is calculate the area of the whole rectangle first. Then subtract the 3 triangles inside the green color. We have 3 triangles. We subtract that. Then we will get the balance will be the area of the triangle ABC. Okay, let us start. We start from the area of the rectangle. It's a length times breadth, 20 times 14, we get 280. Then area of the first triangle, that is PAB, half times base times height, half times x times 20, we get 10x. Then area of triangle CSA, half times x times, what is the height? 14 minus x. Okay, we get 7x minus half x square when you simplify. Third triangle CQB, half times base is 20 minus x, height is 40, so we get 140 minus 7x. Now all these steps, a question of 6 marks, so we are going to now subtract the areas of the three triangles from the area of the rectangle. We write all the terms very carefully, simplify very carefully, then we get an equation. That is our job, the first job. We don't have the area equation. So we get ax equal to half x square minus 10x plus 140, a quadratic equation. Now for minimum area, we are applying calculus only at this stage. A dash x, the derivative equal to 0. When if you imagine the parabola, the minimum, okay, the minimum point, the turning point. At the turning point, we know that the gradient is equal to 0. That is the idea. We apply here. Say we find this derivative x minus 10 equal to 0, and therefore x equal to 10. What is our question? Calculate the smallest possible area. So we use this x value into the equation of the area. Therefore, smallest area or minimum area, a of 10. We substitute 10 in the place of x, we get 90 centimeters square. 6 marks question. Okay. So we finished part 1. More questions can be practiced. You better get more and more questions from the past exam question papers. Prepare. The methods are already with you now. Watch these videos again and again. And don't forget to subscribe and share these videos to your friends. Okay? Good luck.